All right. Hello, welcome everyone. I'm just going to give it just a moment here for folks to be able to come in. Sometimes it can take a moment on Zoom, so we'll get started in just a second here. All right, still see the ticker going up. Once I see it slow down a little bit, we'll just jump right in. So welcome everyone just joining. We're just about to get started here. All right, the number's still going up. It's a good sign. All right, it's slowing down a little bit, so I will go ahead and get started here. And for those of you who joined late, well, I guess you won't hear this, but if you go rewatch it later on, you can catch the beginning or any pieces that you missed. So this will live on afterward online, so you'll be able to view it, of course. So welcome. My name is Steven Sims. I'm the Offensive Operations Curriculum Lead for the SANS Institute. And joining me here is Erik from Buggenhout from Inviso, and also a senior SANS instructor and author. So quick little background about myself, and then I'll pass it over to Erik to give a little background on himself, and then we'll jump right into the content. So the presentation is the Always On Purple Team on automated CI/CD for detection engineering. And of course, CI/CD stands for continuous integration and continuous deployment, or maybe other words that some people come up with. But we did this talk or a similar talk at the RSA Conference earlier this year, and it went over really well. So we wanted to give an updated version of the talk for you. Again, my name is Steven Sims, Offensive Operations Curriculum Lead at SANS. I'm also one of the authors of courses on advanced exploit development and advanced penetration testing. So Erik, why don't you give a little background on yourself?
Yes, thanks a lot, Steve. Yes, I'm also involved at SANS. I take care of the 599, 699 courses, which we sometimes call the purple team classes. What's more important though is what I really do. What I do is I focus on things which are a bit between red and blue, so that typical purple style thing. I used to be focused on pen testing, red teaming, all of that. But since then I've moved along. I've crossed the bridge a bit, and I'm now looking at Inviso in particular. I'm looking at everything we do in managed services like managed detection and response. And the key thing that we do there is detection engineering. And of course, the idea there is how do we get more done with less effort? So this is really the whole principle of this presentation, and also something that we touch upon in the classes is, but how do we make this more efficient? How can we get more out of the efforts that we put in detection engineering? So quite excited to present this topic and to discuss it together. So yeah, that's it for me. Very short.
Yeah, and a bit of my background, I've been doing exploit development and vulnerability research for a long time. I wear my IDA Pro shirt for reverse engineers out there. I started on the blue side and went over to red side pretty early on. And Erik, I think, was more on the red, turned blue, so kind of good for purple, right? The origin of the purple team curriculum at SANS and just the concept in general, from my point of view, came from when I would teach offensive courses on penetration testing and red teaming, whatever else. I would always do this poll, and you may have heard me say this before. I say, how many of you in the room are pen testers or working on the red side? And literally 1/3 of the class on average would raise their hands up. And then the other 2/3 worked in blue or some other areas, which got us thinking, well, a lot of blue people are coming to offensive courses because, the offense informs defense whole concept. And what would happen is we do a lab. Let's say it's a lab on hacking a router or a switch. A student, without a doubt, would say, how do I defend against, now that we've done this attack, how do I defend against it? And the problem was there wasn't enough time in the course with all of the offensive content for us to thoroughly cover the blue side of the house. So I could quickly speak to it, but the students didn't get the hands-on experience of actually correcting something, a vulnerability or misconfiguration, and then go and validate that it actually is working as properly. You can't hack it anymore. So thus, from that came the concept of a purple teaming course, and 599, Erik is the lead author along with some peers of his at the company Inviso. I'm a light author, I'll call it. I have like a half day or day of content in the course. But really, again, it's all about working together as a team, red and blue, to be able to, since we're trying to accomplish the same goal of securing an organization, if we're not doing it together, then we're probably duplicating efforts. We don't have that synergy. We're not going to be as effective. So if you want to jump forward, Erik.
Yes, absolutely. If my clicker, there it is.
So we'll start off with, it's broken up into 4 sections. I'm probably going to do most of the first 2 sections and then let Erik take on sections 3 and 4. And that's by design. I I would not want to do this presentation without Erik here because he's got a ton of hands-on experience in the realm of detection engineering and bringing automation and AI into it as well, which of course these days you can't have a talk without AI, but they're actually doing this. And we'll talk a little bit more about that coming up. I'll speak to it high level and then Erik will jump into more detail. So 4 sections, we'll do a quick introduction here about what purple teaming is in general. We'll define some definitions so that we're all on the same page with terminology, and then we'll move forward as quickly as possible to get to the good content. So let's do a little bit of definitions here. I gave a little brief overview of red versus blue, and it shouldn't be versus blue, of course. When we talk about that, we're thinking of capture the flags and things. But historically, red, the red side of the house, and of course, with that, I'm speaking on the offensive side, pen testers, red teamers, hackers, whatever. In my experience, and many, many people I've talked to, especially going back a decade or two, red was always like isolated. They were this team of people. They were working in a separate building or a separate office that's like locked, and they don't come out very much. And you see the person with the blue hair walk by, and like, okay, that must be one of the offensive people. I'm joking, of course, but there are some consistencies there. I live in the Bay Area in Berkeley, so I've like interviewed and worked at all these places like Microsoft, Google, Amazon, Facebook, at least on contracts or at least an interview, and just seeing all these different teams and such. It holds true, it stands true still to this day to some degree. But thankfully, a lot of that has been broken down a bit, and by broken down, I mean the walls, the barriers, and the communication from the red and the blue side. You would often see that the blue and the red would report to different organizational structures like hierarchies, and they'd have different managers, and maybe those managers aren't communicating. And when you think about it, we're all trying to solve the same goal of protecting the organization or our customers. So we probably should be speaking. And I just said earlier, offense informs defense, but defense also needs to inform the offense. I think about this like example, taking it to a vulnerability research side of the house. When I do something like reverse engineering a product and I need to look at the firmware or reverse engineer the binaries that are associated with it, a lot of companies would say, we want a true hacker's perspective. They would call it opaque box or black box or whatever. We want a true hacker's perspective as to what they see when looking at this product. We don't want to give you the source code or the debugging symbols or any information about it. We want you to treat it as if it's completely new to you and you have no insider information. And that makes sense when you think about it. But when you dig in a little bit, you're like, but wait, I know how to reverse engineer. I know how to decompile code and read through it. It's going to take me time, though. Like, you're just slowing me down. You are not improving the security. That might be even considered security by obscurity. You're not really making things better by not giving me information that I need. Again, I can take that binary that's compiled and we can reverse it and disassemble it and then get it back to its pseudocode. And we can have the closest thing to source code that we can get. So why not just give me that information up front? Because then I can be much more effective and I can do a way better job in assessment given the time constraints that I probably have. And that works here as well. If I'm going to do adversary emulation campaign and we're doing a red team exercise, if the blue side, the defensive side, shares with me how they do their thing, what kind of SIEM they're using, what kind of detection engineering they've done, or just generally anything that could be useful, their network diagrams, their architecture, what types of firewalls they have. Like, give me all of that information. Because just like the earlier example, I can find this stuff out. It might take some OSINT, it might take some scanning and looking around, but I'll be able to get that. The more you give me up front, the more I can tune my attack to try to evade those defenses. And you say, well, I don't want you to evade the defenses, but that's the point of a red team, right? You want me to emulate an adversary to test the capabilities of your SOC and your detection engineering. So by giving me the defensive controls and how you do things, I can see if I can get around that. That's going to be a lot more useful to you because the result of that is then going to allow you to go in and improve your defenses. And just like you told me about what kind of detection engineering and such that you have, I can tell you what type of offensive capabilities I have and what I'm going to be doing. I can say, oh, I'm going to use Cobalt Strike, but I'm going to use a custom implant that I wrote the stager or loader for. So that way, hopefully it gets around your endpoint detection. All that information sharing is helping each other out. And then we work together. We see how far we can get during the campaign. And then afterwards, we work together on a plan to go and put some corrective controls in. All of that stuff is going to be way more beneficial. And then, of course, we can get into the automation side of it and the AI side of it as well coming up. Go ahead, Eric. So how purple do you want to go? And this one thing I want to make a point of is purple team doesn't typically mean a whole new team that specifically does purple teaming, and you've got to hire new people. A lot of us don't have the budgets to do that. It's about getting blue and red to communicate with each other and work together. So to even start, we might identify somebody on the red side who has an interest in helping us with the purple team concept, identify a person on the blue side, and we just start from the beginning. And we have meetings, we share knowledge, and we start looking at how have companies successfully deployed purple teaming in their organization. I was just at DEF CON doing a talk, and I was lucky enough to have some meetings with some folks from Microsoft. And one of the individuals from Microsoft was a manager who leads the red team, the purple team, and some other groups that are all offensive. And it's interesting to get the perspective from large companies and mature companies like Microsoft, because that's who you typically want to model yourself after. And I know a long time ago, decades ago, Microsoft, we would make jokes about how insecure the operating system was. But nowadays, that's just not true. And Microsoft's turned into an amazing company in terms of security and capabilities. So it's a good one to model after. I mean, I remember back when Microsoft came out with the security development lifecycle back in 2003. And organizations still use that today. And if you're not familiar, the security development lifecycle is all about mapping security controls into each phase of the development lifecycle. So historically, if we weren't doing code review or static analysis and fuzz testing or dynamic analysis, or looking to see what kind of mitigations in the compiler that we're putting in, or secure cryptographic design and threat modeling and attack surface reduction, like all those things I'm rambling, that's all part of the SDL. So again, I'm using that as an example because Microsoft's a very mature organization. It just came to my head when thinking about a company that's actually doing purple teaming properly. So when we get started, we got to start somewhere. And that's why I said we can have somebody from the blue side, somebody from the red side, especially those individuals who are like really wanting to do that. Obviously, with those types of volunteers comes, well, a better job security because you're doing more than you were before. Opportunities for promotion or more financial incentives during your annual review. Like there are always going to be people who want to raise their hand and then step up when you have those types of new opportunities and challenges. So we can start from the beginning. We're just using basic Microsoft Office suite tools, and we're looking at different campaigns people have done out there. Look at the MITRE attack framework and all the different mappings of different adversaries. And we could just start low because it's not something that's going to happen overnight. And then we can, of course, get more advanced, and we can look at different frameworks out there that exist that have been tried and true. We can use tools out there to help us that have been designed specifically for purple teaming, like Vector. And then we can continue on and just get better and better. And then we can have continuous purple teaming. Eric's going to talk about automation and the AI component and such. But real quickly, like an example would be if you've got let's say you have a managed SOC that you're using. So you've hired some organization, third party, to take all of your logs, your alerts, and all that from all of your facilities, taking in, and then a different organization is kind of being your SOC. So with all that data coming in, what do you do with it? And obviously you could take that information and you can go manually look things up and try to put new detections and capabilities in, but wouldn't it be better if we could automate that? So something there that's ingesting threat intel data from across the world and able to make, again, the AI component would be to dynamically take in the logs and alerts that have come in specifically from your organization under whichever vertical you fall under, take that into consideration along with the other threat intel data, and then generate new Yara or new Sigma rules dynamically and then publish those. Like that's getting more into the automation side and using AI. But again, Eric's going to get into that soon. So you probably all seen the Magic Quadrant before out there from Gartner or other interesting tools that have been built or ways to display data. This just shows us the hype cycle for, I guess, Magic Quadrant and the hype cycle, right? This shows us for cybersecurity operations from 2023. As I'm sure you know, it usually takes a year for last year's data to come out. Like just a couple months ago, we got IBM's annual breach statistics. And I love that report because every time that report comes out, I look specifically for things like supply chain attacks and how do software supply chain attacks how are they related to the number of breaches? Like what percentage of breaches that occur are related to software supply chain issues? And that number seems to always hover around 15%, give or take a couple points. I remember one year, I think it was like 2021 or 22, it was all the way up to 20%. So like that is a tool that tells us we should be taking that more seriously because it's the cause of 20% of breaches out there. And of course, software supply chain issues being things like using open source software or libraries compiled into your projects, your code, or the applications that you use. And obviously, if a vulnerability ends up being in some library that's open source used by a ton of different vendors out there, then that's a huge issue. So that type of data becomes very useful. And you've got all these different companies who are experts in this craft giving us this information, telling us about their experience with products and breaches and what types of products they have. And we're able to, do this type of research and make it applicable to our organization. So like it says there, BAS tools, I'll go back one more time. BAS tools, so like breach and attack simulation tools, I guess we could say. That's never going to be a substitute for expert-driven red teaming. Like same thing with AI. Like if you follow Google Project Zero, one research area that they did recently that I was very interested in, I used it in my presentation at DEF CON, was nap time, they called it. Nap time, like going to sleep. That was about using AI with regard to vulnerability research. And you'll see why I'm bringing this up. And if you have questions, of course, please do post them. We're going to look at those at the end, though, because we want to make sure we're able to get through everything in the allotted time. But we'll absolutely take your questions at the end. So don't feel like you're being ignored if you have posted something. But anyway, back to nap time. I'm a vulnerability researcher, meaning my job is to identify attack surfaces. And that could be a driver, it could be a library, it could be an application, it could be a product, it could be anything. So identify some attack surface and then try to identify opportunities to find vulnerabilities. So I might do things like fuzz test it, so sending malformed data to different network protocols, intentionally trying to crash the process. Or I might create different documents that are opened by a browser or an Office application to try and get it to crash. These are malformed documents. So that's fuzz testing, also known as dynamic analysis. So I might do things like that. I might do a little bit of reverse engineering, of course, if I find things. I use AI now quite consistently. And how I use AI with regard to vulnerability research is I will, like, here's an example. I always complain about the function memcopy. Memcopy is a C function, C++ function that copies data from a source to a destination. So anytime you're copying data from a source to a destination, you need to make sure that the destination buffer or location is big enough to hold what you're copying, right? So with a lot of functions in the past, historically, we've had problems with functions lacking size arguments. It's like stir copy. I'm sure you've heard of the infamous stir copy. It only has a source and destination argument. So there's no way to validate that the amount of data that's being copied is small enough to fit into that buffer, right? With memcopy, it does have a size argument. So great, we've got a size argument, but that doesn't mean you're safe. You've got to make sure, because a lot of times that size argument is not static. It's dynamically constructed based on data that might be user influenceable, if that's even a word. So take, for example, the old bug DNS-SIG-RED. That was a bug discovered by Checkpoint, and it was a vulnerability in Microsoft DNS services, right? And so you think about DNS, you think, oh, UDP port 53, and these are small packets that allow me to map a domain name to a IP address. But DNS is so much more than that. And when you're identifying a new attack surface, you want to go deep. You want to read the RFCs and get deep down into it to try to figure out what are all the features of this protocol or this file format that can potentially influence the data, make it corrupt, and cause a process to crash. And they were able to do that with DNS by using TCP port 53 instead of UDP, which of course is connection oriented and allowed them to use some of the DNS features that are more obscure. And they were able to discover that if you create a malformed DNS request, so you craft this thing up intentionally to be harmful, and it's a very large packet or series of packets, it comes in and they discovered that there was an integer overflow vulnerability that led to a heap overflow. So why am I saying this? Because I was talking about memcopy. Memcopy was involved in that vulnerability. It's not memcopy's fault. It's all about how that size argument is constructed, and it's often done dynamically. So what I'll do to map it back to AI and to bring it back home is I will find an attack surface. And recent one I was looking at was Microsoft Terminal Services. And I'll look inside these libraries for things like decompression functions or decryption functions or de-encoding functions, decoding functions. Those oftentimes are complex by nature. And if you're doing something like, imagine you're in a terminal services session like RDP, Remote Desktop Protocol, Microsoft Terminal Services, with a remote system, and you want your packets encrypted, of course, and there's tons of data going back and forth because we're screen sharing literally, right? So all this data is being decompressed or decrypted. The ability for the recipient system to decrypt or decode or de-obfuscate whatever that data and just constantly be copying it to a destination, a memory copy operation is going on. So the way in which that size argument is constructed is going to depend on the data that's sent. So I will feed AI a very complex function associated with decryption or deobfuscation or decoding. And I will say, hey, AI, can you take this decompiled code that includes a call to memcopy and try to help me understand how that size argument is being dynamically constructed? And it does an amazing job. This is especially true when you don't have debugging symbols and other, but like, what is my point of all that? Because I kind of went on a tear there. It is to make it back to no substitute for expert-driven red teaming. Google, after all that research with Project Naptime, came back and said, we are a long way, if ever it's going to happen, from AI, from machine learning, being able to substitute a human in association with vulnerability research. It's just too complex. It's never going to be a match. So yeah, we can get closer with continuous pen testing, red teaming, and automate a lot of this, but it's never going to be the same as somebody there. So hopefully that's good news for you if you didn't already know that we're still going to be needed, thankfully. So go ahead, Erik. Great. So I'm going to ask Erik to speak in on this one, but from a high level, just because he does this for a living in his job, from a high level, you've got these different detection sources. These could be endpoints running EDRs or antivirus and event logs that are coming in. It's a ton of data, right? Every one of these logging facilities could be an enormous amount of information. Right? Look at dmessage on a Linux system, right? Network level, it could be a DNS data. It could be anything coming from IDS or your HIPS or whatever. Infrastructure, so stuff coming from on-prem, from the cloud, your identity, where we're doing things like authentication, whether it be the cloud or on-prem or a VPN concentrator, whatever. My point with that is just there's a ton of data coming in. So we need to normalize this stuff. All these raw logs coming into a SIEM, we normalize it so it's all under one consistent format. We've got our security events coming in, which are the things that we want when we're doing instrumentation and putting detection engineering on these systems. And then all these security events after triage go into something like a SOAR platform or Tines or whatever else you want to use. And we do things like execute our TTPs, so our tools, our tactics, our techniques and procedures, all that fun stuff. We review our detection playbooks. We visualize the results on these beautiful SOC dashboards that we love to see. And then we go in to try and do automation with this. So Erik, you want to add something here?
Yeah, sure. Thanks a lot, Steve. So I think fundamentally, as Steve explained, is most of you, if you're running a SOC or if it's managed or you have it on yourself, probably you'll have a SIEM indeed, which is ingesting raw logs. You might have certain systems which directly produce security events. Take typical XDR solutions, right? But the whole point is that you have a SOAR, which has playbooks to basically deal with those events and instance. Now, one thing here that's on this slide, which I haven't mentioned, and which Steve didn't touch upon yet, is the best tool, right? So this best tool is really where it gets interesting, because a breach attack simulation tool, as previously mentioned, indeed, it's not a substitute for expert-driven red teaming, but you should ask yourself the question: how much of that, or how much of your detection engineering efforts, is about creating that crazy new detection use case for an exotic thing that you still need? Yes, there is a part of that work, but the more fundamental need is, okay, but what's your current coverage? Can you test it? Can you test it in an automated fashion so you can do it repeatedly? So in this design, and we call it on purpose V1.0 because we've upgraded on top of this, of course, but that's actually what we present at RSA 2023, where we said, okay, but we can use a BAS tool to trigger TTPs to run on those endpoints, on the source systems that you're trying to protect. And then, of course, the SOAR it basically instructed a TTP to be executed through the BAS agent, right? So it knows, hey, I tried to run a test on that system, and it can then listen in to see, am I seeing detections for that, right? Because all of the detections are being sent to the SOAR engine or the SOAR platform anyhow. And by correlating that, you can then start creating deductions, creating conclusions or summaries like, okay, this TTP that I just executed, yes, it's covered by a detection, yes or no. So this is the first step towards saying, let's build something in a bit more of an automated fashion. Of course, this is just a start because we're going to build on top of this. This is a small dashboard, just as a heads up. This is also what we built in 2023. So this is a specific SOAR platform called XSOAR. As Steve mentioned, though, you can also build this, of course, with Tines. Any kind of platform that you would want to use is perfectly fine. But this shows an example of, indeed, you can see here, number of emulated techniques, the number of detections, a nice percentage total technique detection rate, just to show that you can build a nice dashboard to basically control your continuous purple teaming, if you would like to call it this way. Now, of course, this will only just tell you have a detection or not, and we want to go beyond that, of course. Steve, if you want to.
Yeah, let's jump forward.
Yes.
Cool. So now we have a short section on problem statements. Let's jump right into that. I'll give one more example or switching slides here, just because I had about half a second of time. But so I'm going to give one more example of like when we started this course, and the course I'm speaking about is $5.99, which is a Purple Team course at SANS, and then we have $6.99 is the advanced one. To give an example of what I mean by red working with blue, identifying a problem, going and putting corrective action in, and then validating. One was Credential Guard. Like Credential Guard is that was one of Microsoft's earliest implementations of virtualization-based security. Virtualization-based security, I'm sure you've heard of it before, but that is what I consider one of Microsoft's best mitigation toolkits, or whatever you want to call it, out there. It comes with various mitigations like HVCI for hypervisor code integrity, and it basically takes hypervisor. So you have ring -1 now. So ring 0, of course, is the Windows kernel. Ring 3 is user land. And then ring -1, it's kind of a fake ring, but it's a hypervisor, and you're kind of shimming it in or sticking it in between the kernel and the hardware, because usually the kernel is what's controlling the hardware and directly accessing it. But if we stick a hypervisor in between the kernel and the hardware, now it's the hypervisor that's controlling the hardware and managing things like the hard drive and disk space and all that. And then it's able to run multiple kernel instances. So early on with Credential Guard, Microsoft utilized that, and they create a second kernel instance called a secure kernel, utilizes something called secondary level address translation, which gets quite technical in how it manages virtual memory. We don't need to talk about that. But then you've got a separate user land, and you've got these things called isolated user mode processes. So if you're familiar with the tool Mimikatz, that's an infamous tool, a brilliant tool that attackers have used for years, pen testers have used for years, that allows you to inject into the LSAS process, the local security authority subsystem that has your credentials in it, and it's able to steal the clear text credentials out of the LSAS process that runs in user land on the user system. So one example of what we did in the class to demonstrate what purple teaming could be, or at least a part of it, is we had the students use Mimikatz, get the LSAS process, inject in with, and then steal the credentials, and then turn on Credential Guard. And what that actually does is it creates a new process called lsaio.exe. It's like a separate LSAS process that's protected. It's running over there in a secure kernel isolated user mode process. And that has the credentials now, and they're encrypted. So if you were to run Mimikatz on the regular Ring 3 host system, it'll inject into LSAS, but there's nothing useful in there anymore. In order to get to the real LSAS process, you've got to go through a broker, through the hypervisor, over to the secure kernel instance, to the isolated user mode process to be able to get that. And Mimikatz can't do that. So we had the students implement that, and then they go and validate that Mimikatz then doesn't work anymore. So that's just a quick example I wanted to share. Probably should have said it earlier on, but that's kind of stuff we're talking about here. So testing is silver, right? Improvement is gold. So at least it's kind of like intrusion detection versus prevention. And you've probably heard that saying, detection is ideal. No, prevention is ideal, but detection is a must. So we at least need to detect things so that we can respond to. If we're not detecting, that's what gives attackers a good dwell time when they've hacked your environment and they've got a breach going on, right? So we want to be able to detect at least, but of course we'd prefer to prevent. So if we were look at our logs, our platform, whatever, our dashboards, and we determine that there is no detection for a specific TTP, then maybe we can go in and look at a Sigma repository or Yara or whatever else out there and say, are there any existing signatures written that we can then deploy, or rules written that we can deploy? Okay, we found one. Let's deploy it into our environment. Let's run another campaign and see if it actually catches it that time. And if it does, great, we've improved it. Now that's very manual, but it still works and it's good. If we can automate that, it'd be a little bit more helpful. And I don't say automation as a way to replace people. I, of course, don't want to see that. I think automation is a great way to make us more effective because we've got so much to do. A lot of us aren't working in an environment where we're lucky enough to say, hey, we need a few more bodies. And like, okay, go hire people, like unlimited resources. So we've got to use things like automation and AI when appropriate to make us more effective, not as a replacement. So testing is silver, improvement is gold, continued on here. It's nice to have a dashboard that tells us what TTPs are detected, but to improve, we need detection engineering, right? Something, even if it takes a few minutes for us to do it, if we can automate that, it's going to save us time in the long run.
All right,
Great,
thanks.
Erik, if you want to take over for a bit, I'll chime in if you need me to anywhere.
Yes, sorry for the slide back and forth. I'm doing the little click and then push of the button. So
And my
then
pupils are following the mouse cursor you kept using. I'm like, why is he doing this? Making me dizzy.
how was I moving? I'm sorry, my apologies.
Sorry.
So a vision for the future. So detection engineering is great, but indeed, can we get it on steroids and can we get more out of it? I'm a lazy person, so I like to find things to automate and to simplify. So we start off with a very basic premise to say, okay, let's test this out. A vanilla ChatGPT, right? Just basically the one we all know. Can it generate detection rules? Interesting. Let's give it a try. So I'm now addressing ChatGPT. I'm saying create a KQL query, which is basically what Microsoft uses in Defender for Endpoint, because that's also a big point. Sigma rules are great, but then of course you still have to convert them to the actual platform that you're using, the technology stack. And I'm looking for technique T1003.001, which is actually the one that Steve was expertly discussing, which is basically the credential dumping from LSAS. So you can see it's all perfectly aligned. But what do we see here? Yes, ChatGPT comes back with something, but it makes a few assumptions. It's assuming you have Sysmon data in the security event table, and you can see that it's targeting event ID 10. So for the people who know, Sysmon event ID 10 is basically a process access event, meaning that the handle towards the process was opened. So yes, indeed, Mimikatz is trying to access the LSAS process. So that's what you're seeing here. The target image indeed would be lsas.exe. And then, of course, there's a granted access, which is basically an access mask. If you're familiar with typical rules that try to detect credential dumping from LSAS, you will see that in Sigma repositories, that access mask can have different values. But it's more of a, let's call it an artifact of a tool. If you would take Mimikatz, it uses a specific access mask to access LSAS. So it can have a few values. So that can potentially work. And then it actually has an account name doesn't equal system. So it's using a couple of exclusions. All right. So general, let's call it evaluation of that rule. The detection logic as such is relatively sound. Yes, if someone is doing that credential dumping from LSAS, likely they'll try to create a handle. The proposed format is also the right one. It's definitely a KQL query. The rule, though, is likely prone to a few false positives but that's with many of these rules which try to aim for LSAS detection. Well, because you need to, it depends on the environment, it depends on what's in place. Also note, it's actually assuming that you have Sysmon deployed now. To be fair, not a lot of organizations have that deployed enterprise-wide, but overall, it's not hallucinating. It's not bad, right? It's a good start. So we then said, okay, but can we build a fully automated pipeline to leverage this, right? So leveraging a SOAR to execute a series of TTPs through a BAS tool. That's what we described in that continuous purple teaming version 1, that architecture. So we use a SOAR to instruct the BAS tool to run a series of TTPs on the endpoints using a BAS tool. We then leverage the SOAR platform, which also gets all the security events to compare, okay, I execute that technique on that system, but I don't have a detection. If I have a detection, though, let me start with the positive case first. Fine. I execute that TTP, and guess what? 5 minutes later, I got an alert from that TTP on that host on which I did the test. It's detected. So I will mark it as detected. We have coverage for this one. Note that careful with binary or being Boolean about this, right? This is not true or false, and I'll get to that in a bit. But again, we have to start somewhere. But careful with just marking. I detect that specific variation of a technique, so I'm fully covered. It's not Boolean, right? There are many variations, obfuscations, all of that, but we'll discuss that in a bit. But if we don't have a detection, okay, let's again assume that we're lazy. Let's just interrogate an LLM to propose a suitable detection analytic. Say, okay, but for that technique, can you give me a detection analytic for my specific infrastructure, like I just showed you on the very simple ChatGPT question. We then run a series of tests or validation on that detection analytic. What could be some tests? How many events does it return? Because if it's if it's a search that generates thousands of alerts, it's not good, right? It's not fit for use in production. So we'll have to review and fine tune it. That's of course the manual step. And then if you are satisfied, you would say, okay, but let's now try to deploy this detection analytic in a sort of acceptance testing mode, right? So where we see what comes back. Let's make this very concrete. So we make a version 2.0 of our architecture, and you still have the same components. You have a test system or endpoints on which you are testing stuff, where you have, let's simplify this a bit, a BAS tool running, the breach attack simulation tool. Logs are going through a SIEM into the SOAR, but now you can see in the SOAR that we added a few components. We added a few playbooks, basically, which are going to potentially try to generate detection rules if there is no detection. And for that, we're just going to use an LLM model that we call from the SOAR. So we're basically going to say, hey, would you have a detection rule for me for this specific technique? We're also going to try to deploy that rule on the SIEM and then rerun the TTP to then see if we get detection. So we're actually building a bit of an automated pipeline, effectively, which is going to suggest a TTP and then try to run it. So what would that look like in practice? Here's one implementation. And you could say, oh, does this only work with XOR or Sentinel? Obviously, it's a concept. It can work with many different tools. We just used a setup that's quite common and that we work with a lot. What are we using here? We have a user, that's bottom left there, who launches an emulation plan. So you can see that the user only interacts with the SOAR platform. I like that because in our managed services, that's also often the ambition, single pane of glass. So they work with that SOAR platform and they're going to launch an emulation plan. We're going to say, let's execute these 10 TTPs. The SOAR will talk to the BAS tool. In this case, we're using MITRE Caldera, which is an open source and free BAS tool. There are commercial alternatives as well. You can choose, of course, what you want to do with that. And then, of course, it's going to execute those abilities, those TTPs on the endpoint on which the BAS agent is deployed. Security logs are being forwarded into the SIEM, in this case Sentinel, and those security events are being pushed to XOR for further picking by analysts, of course. Now, of course, the XOR will do the checking. Did I get a detection now for the TTP that I just tried to execute? If not, let me talk to ChatGPT and ask for let me basically ask it for a potential detection rule, which I can then deploy on Sentinel and rerun my entire campaign and have my analyst actually review the suggested detections in between. So again, as Steve put it very cleanly, and I love that, I like that a lot, we're not trying to replace the human. The human has to stay in the loop here because otherwise it's going to go haywire, but we're just trying to make them much more productive and get a lot more output. And does that work? Well, I'll show you a demo. So it's really, the proof is in the pudding, but very short. Here's a couple of screenshots. I'll be brief because you'll see it live. We have an adversary in Caldera, which is basically, in this case, Alice 2.0. It's just a listing of TTPs that it's going to execute. And you can see them here listed one by one. You can build your own, you can add your own. Caldera comes built in with about 1,600 abilities. Abilities are TTPs, right? So it gives you an idea. About 1,600 TTPs can be emulated out of the box with Caldera. Not bad. Now, in the SOAR platform, we are going to create a new incident. Now, the terminology of a SOAR platform, it's about handling incident. That's why it's called a new incident. But the incident that we're creating is actually a Caldera operation. So we're specifying that we want to run a certain adversary campaign. You can see here that Alice 2.0 is in that list. We can select it. And then we can also specify on what systems we want to run it. Once we start running this, you'll see that there are, as you can see here, there's a whole bunch of TTPs being executed, one of them being T1033 system owner user discovery. The command that's being run by the adversary is who am I? Well, obviously enumeration, right? Status success means it was successfully executed, detected false, right? So our playbooks determined, we didn't get a detection for that. So that would be one that you might want to improve upon. Now, of course, if you ask an LLM, give me a detection for that specific system owner user discovery, it might just come back with something like process creation and then process name includes who am I. It's a bit silly, right? So this is again a good example of where you probably want to have some human effort involved. What's interesting though, for the local group discovery, you notice that already a detection was built in, so that indeed, of course, that Sentinel Defender for Endpoint stack comes built in with a number of detection analytics. So as I mentioned, we could then say, okay, we have this who am I command, for example, does not get detected. What we've done in our SOAR platform is built in a dynamic prompt generation mechanism. So it's like a lot of words for, it's basically generating a prompt saying, okay, but we've now ran this technique. We didn't get a successful result. Can you suggest a detection rule for us? And then you can see here, indeed, as I mentioned, the who am I command, ChatGPT, what it will come back with, in our case, with that prompt, it will say, we're looking for a security event, but event ID 4688 and 4689, that's basically process creation. It's command line auditing, and command line contains who am I. Yes, technically correct, but also a little bit brittle, because how would you typically want to detect reconnaissance? Probably you're looking for who am I, host name, net user, a couple of those commands running in the space of 5 minutes. That's probably a good one to detect reconnaissance. One single event isn't really proof of reconnaissance. It's probably just an administrator running it. So this needs a bit of work. As said, you need a human in the loop here to then determine what's going on. But what's very interesting, and this is where it starts getting useful, in my humble opinion. We have an initially generated rule by ChatGPT. Step one, right? As I showed you here for that who am I execution, we then tried to actually push it. We said, okay, let's take that rule and push it on Sentinel. Step two, upon Sentinel import, the generate detection rule appears to throw an error. You can see it there in the middle of the slide. Bad argument error. The request had some invalid properties. It's giving me an error. I'm lazy. I don't want to analyze the error myself. I just take the error and I push it into ChatGPT and I say, hey, if I use that rule, it's generating this error. And actually, you'll see that ChatGPT is sufficiently smart to come back with, it's because the process command line does not exist in the security event table. You probably want to use command line. So it corrects the query. And then you can see at the row below, we push it again. And then it says valid query true, because this is indeed a valid query. But the query result is 29. So it tells you already this rule. And we configured it. I think we used 1 day or 2 days. It checks the history of that system, the past 2 days or 3 days. I don't remember. I'll double check it. How many hits do I get for that search? If it's 29, guess what? It's too much. It's not a proper detection analytic. But then we take that info and we say, hey, ChatGPT, I've got this detection rule, which you gave me. I've got 29 hits in the past 3 days. Do you think this is a good detection rule? Yes or no? And then you can see that it actually adds a bit of guidance to say, this might be a bit too false positive prone. We all agree, don't remove the human from the loop. But can you imagine how this can speed up detection efforts? Because there's no more, let me try to push that rule. Let's check it. How many results do I get? Because we built the whole playbook scheme around it to make it much more effective and just much faster, if you will. So what are some of the problems that we used? Work in progress, of course, but we have one for initial detection rule creation. We have one to try to fix the errors that come back. Again, the goal is we try to be as lazy as possible. So when there's something, we try to first have AI fix it on its own to see if it works, and then assess whether the rule is sufficiently accurate. These can, of course, be further adapted. Again, ambition, supercharge detection engineers, not replace them. So let's just show a short demo of this in action. So I'm going to flip over my share here. It's a very dangerous moment in any presentation. Everyone's like, don't do it, Erik. You should be seeing my
Yep.
beautiful Windows Media Player screen here. So I'm actually going to walk through those screenshots. I'll talk while it's ongoing. Again, it's also in the slides. This is also something we've published, so that video is available. But you can see here, we're creating that new Caldera operation as an instant in XOR. We're giving that a name. It's of course demo, and then we're specifying what adversary we want to run, bad guy in this case. This is a bit more metadata, not too interesting, but how we want to run the the operation, the jitter, the group, create a new incident, and it will start running. You'll see that it sometimes cuts out a bit because it needs a bit of time. There's also Sentinel in between, so there's a bit of, by the time that the cloud got the security event, it needs a bit of, so here you can see the result. It tells you that it's still running. These are the techniques that it's going to be running. I zoomed in for a second here. You can see the overall operation summary. So currently no detections, it's still running. So that of course makes perfect sense. Here we then, yeah, okay, that's again the configuration. And then you can see there really the detailed log of everything that was executed, all the different commands. So it tells you this is what I'm doing here, what I'm building. Just skip ahead for a second. All right, so here now we are at the real operation results. So you can see here detection rate 2 out of 7. So we got 2 detections out of the 7 total techniques that we executed. That's quite interesting. It also references the specific incidents in Sentinel that are detections based or that are coming out of my best tool execution. And then we can actually go into that. And this is very similar to the screenshots I showed. You can actually see, okay, these are detections that I had, yes and no. So you can see the default operation results. Next step is, of course, to then try to generate those actual prompts to see if we can create detection rules. The nice thing here, again, we offer the ability for the person who is running this exercise. You can, of course, adapt that prompt. You can add additional context or say, don't do this or that. The whole point is that you're facilitating the detection engineers, not replacing them. So we're adding a bit of context about the Sentinel table that has our security events, just as context. And then, of course, we're running that prompt. Yeah, this one here, adversary emulation control use command. It's a very specific detail, but it is the ability to tell the prompt, this is the exact command that we use to emulate TTP. Do you want to give it to your AI or not? It depends. If you give it, of course, you're going to tempt the AI to say, I'm going to build a detection use case specifically for that command, right? So you, again, mix and match, play with it, test it. That's the whole point for our detection engineers to see what gives you the best output. And I'm going to jump ahead a little bit here. Just to show you where we are. I'm being aware of time because there's a second part we'd like to discuss as well. You can see here that we are now going to get those KQL queries for the techniques. We actually now select all the different techniques. What's always nice is to show work plans like this. People love it, but this is just the logic that we built in XOR to run through these different playbooks to really see, okay, what do you want to do? Reach out to ChatGPT to get a KQL query. And then this is the results of the entire thing where you can actually see, of course, not a perfect rule because this is a pretty massive, you can see it's a bit simplistic in the type of rules that it comes back with. But in essence, what we're trying to show here with this initial demo is you can actually speed up the detection engineering efforts quite strongly without replacing the analyst, honestly, because it's a bit too simplistic. But there's more. So we want to, and I'm again going to jump back to my my PowerPoint presentation here. So preliminary conclusions for this. Atomic TTPs, I think you should be continuously testing them because that's something that you can fully automate. And what do we mean by an atomic TTP? Credential dumping from ELSAs. It's relatively simple to do. Running that specific, for example, a Mimikatz command, that's something you should be continuously doing. You're not going to hire an expensive red team to tell you that you don't detect ELSA's credential dumping, right? I hope that you're testing that for yourself. What you hire an expensive red team for is to emulate an entire adversary A to Z and bypass your controls as they go through it, right? That's the whole point. LLM models can definitely be a force multiplier. You've seen it. I think it really, when used well, it can speed up the efforts. But of course, you need a human oversight. That's very clear. So very similar to what Steve said, we're not going to replace detection engineers anytime soon. However, it gets better. Increased capabilities. So there are techniques like RAG, which is retrieval augmented generation, where you can basically have a large language model, add additional context or documentation. And that's something that we've actually started playing with to say, can we use it to learn Sigma rules and understand, for example, the Caldera API? Why? We'll get to that. We also implement a PDF parser, which allows the LLM to then parse threat intel reports. You could say, but Erik, what are you guys doing? We want to use AI agents together to come up with what I would call to come up with a way to automate the detection engineering process a bit further, not entirely, but see how far we can get, because there are still quite a few things that need to be solved. For example, you want to be doing detection engineering. You want to do that for TTPs that matter. What TTPs matter? That's probably a question for your threat intel analysts. Okay, we're this type of organization. What are the most important TTPs to us? And you might at one point get a report from management which says, hey, here's this new threat intel report. It's got those 200 TTPs being referenced. Beautiful. But yeah, how do we fare? How do we stack up against that? How are their defenses doing against that? That's a lot of work. You need to extract all of the TTPs. Do I have detections for them? And that's the problem that we're trying to solve here. And what we're doing here, we are showing a proof of concept where we leverage AI agents using, for example, Crew AI, which is a framework to have multiple autonomous AI agents talk to one another and give each other instructions. For example, you have a threat intel analyst, which is basically a prompt which is going to read threat intel reports and extract MITRE ATT&CK TTPs out of those. Then you have red team operator, which says, okay, but for that TTP that you just gave me, I now built a Caldera ability. So you're basically building additional abilities and thus emulation plans in the best tool. And then finally, you have a detection engineer, which says, okay, give me TTPs and I'm going to generate detection rules. If you put all of that together, we're building something pretty nice here. Because what you can then do, I have now reached my final state. You can do something like this, where you basically say, okay, still the same thing. We're using a bus tool, we're using SOAR, but now we're also having our LLM model parse TI reports and create additional abilities in the best tool. Simply put, it's an answer to this problem. And this is something that we actually have in the second demo. So if time permits, we'll just push that one through as well. So you get the full picture. You take a PDF, a new threat intel report from CrowdStrike, from Palo Alto, from Microsoft, who knows, which lists or which just describes a new amazing campaign by a new adversary. And the question is, how well do you fare against that? With what we've built, you can now take that threat intel report, feed it to one of our LLM models or LLM agents, if you will. It's going to extract TTPs, build abilities in Caldera for those TTPs if they don't exist yet, and then start running them as abilities on your test systems, then mapping them to detections to see if you have the right detections, yes or no, and highlight coverage gaps and even suggest potential detection rules to close them. I hope you all agree that's a massive improvement of our time and effort. And of course, you'll still need humans to actually make it work, but the potential gains here are quite amazing. And I'll end with a small demo. The second one here that we have, and then we'll actually will be full circle because aware of time, we have 8 minutes left. But this is the last thing that we wanted to show. So I'm just opening my second screen here. I'm going to share my screen again. Yeah, sorry about the rush a bit, but you can see it's a very fascinating topic, so we can just keep on going. So what we're doing here now, we're actually going to download TTPs from an HTML report. So we're actually specifying, hey, here's you can see here the dfirreport.com from ID to Dagenlocker ransomware in 29 days. Okay, it's going to try to extract the MITRE ATT&CK techniques from this threat report. So it starts working. So this is basically an implementation of an LLM agent that we did. And you can see here already, you can see that there's also a coordinator agent, which is basically making sure that everyone's getting along and the AI agents are playing nicely. But you can see that it's extracting all of the different techniques. So it's listing them all here. You can see it's a pretty big list. Okay, so that's a nice extract of all of the DTPs from the report. Fine. There we go. Yes. So next step. Yeah, sorry, this is, excuse the output, but it's on purpose. But so what it's now doing, it's basically using these techniques and is then checking, okay, it's talking to the Caldera API because we actually gave it the documentation of Caldera, and what is very funny, there was a typo in the Caldera API documentation, which caused our entire agent to break. Because the funny thing is, it read the documentation and it says, that's how I need to interact with the API. But because there was a typo in it, it broke. because it just took the instructions as it got them. So we mentioned that the Caldera has been fixed since then. But quite interesting, we don't learn it how to deal with the Caldera API. We just tell it, here's the manual, figure it out yourself. And it's quite effective at that because it just reads the whole thing. It now maps all of the techniques with existing abilities in Caldera, and if they don't exist, it creates them, which is pretty nice. It's going to now create an adversary profile with these abilities, so a new emulation plan, if you will. Sorry, lame Terminator jokes, but when the text is a bit too heavy, I added something like this. There we go. And then rinse and repeat the whole thing. Now you'll see that there is actually, oh, this is very fast, but there is now an APT adversary in Caldera, which is actually generated by our LLMs. And now, again, this is the human again coming in. It's running the whole thing that I just showed you in the first demo. It's running that all over again, and that's why it's going so fast now. But you can see how we put these two things together. And yeah, I must be fair, it's quite an exciting prospect, because now you've built. I showed it to you now very quickly, but it's as simple as that. Okay, there's a lot of effort that goes into building all of those playbooks, the logic, the prompts, but the result is, and I'm going to go to my shares again, my slides again for a conclusion. The result is a highly effective detection engineering pipeline that can really work very effectively. So these are the final conclusions. I think atomic TTPs, you should always test them continuously. It only makes sense. LLMs and automation can be a force multiplier, obviously, because it can speed up a lot. You do need human oversight, as already mentioned. And finally, and then I'll hand it over to you, Steve, for some closing remarks as well. The use of concepts like AI agents, there's Crew AI, which is a very well-known one. Microsoft has another implementation, but reverse augmented generation, stuff like that, can be very helpful to build additional workflows of increased complexity. So when being smart, you can really you can generate quite some interesting value with all of this.
Great.
Questions?
That's awesome, Erik. Thank you. Yeah, let's just use the last few minutes here for a couple questions, if you're cool with that, Erik.
Yeah.
All right, so first one, I'm not going to be able to get through all of them probably, but let's go from the top to the bottom. Do you have a step for logs going dark, as in a telemetry fail? Detection doesn't necessarily mean detection fail.
Yeah, it's a fair point. In that case, we haven't automated that on our side. How we do it in managed services is we basically have health monitoring to see if the telemetry is still coming in. But you're very right. If you don't have the telemetry, forget about building detection logs, right? Then they're not going to be effective. So it's a very good argument. Don't forget about the telemetry gaps. Yeah.
Where can CI/CD tools like Jenkins, GitHub fit into the automation pipeline?
Yeah. We use, for example, a lot of GitHub to store our detection rules. So it's really just a matter of how you use the tools for yourself, right? Oh, there's someone. See another screen coming up. Yeah, it really depends. We use GitHub, for example, for that part where we have the detection rules. We use that, and we have automated. We've actually on our detection engineering side, if a new commit is done with detection rules, they actually go through this process for testing. So it's basically how you would want to do it, but it perfectly integrates with tools like that. Yes, absolutely.
Great. Another one is how do you go about testing or emulating with an EDR present and running? Do you run two tests, one with and without an EDR being enabled?
Good remark. Because that's the thing with EDR and without an EDR being enabled. Let me think. The danger of running with an EDR fully deployed is, of course, that it will also try to prevent stuff. I would advise, depending on what because that's why I also like to split red teaming versus purple teaming, because on the red team side, you would want to test, but am I also stopping this? And the EDR is probably also going to try to block stuff, right? Because it does two things. It does detection and response, but it's also going to actively prevent because it's also next-gen AV. So I would say on your test systems, try to have it in a way where the EDR is not going to interrupt the actual operation of the technique, because if the technique cannot be executed, of course, you also cannot test detections. It's a bit of a, let's assume failure on the prevention side, and let's assume that it can be executed. And that is something that we can do. I think that's a bit how I would approach it.
Yeah, I think we have time for like two more. Erik, are you working with Raptor framework and vector database?
It's a good question. I would need to check in. There's a few of our guys who built a lot of the LLM components of this. But if you want, send me a quick buzz on Twitter and I'll get back to you on that to just confirm, because I want to avoid that I say something silly on that.
Sorry, say it again.
I mentioned if you wouldn't mind reaching out to me on Twitter for that
Oh,
question.
okay.
Person who asked it, I'm happy to respond, but I want to double check something with the engineers who've been working on this as well, that I don't say anything silly here.
Yeah, so Alberto, hit up Erik on Twitter.
Thanks.
Do you have a GitHub that shares the configurations on the agents?
You mean the live response, but you mean the configuration for the LLM agents, or the ones who are the
I would imagine the LLM, but I'm not sure.
yes. So if it's the LLM agents, yes. I just need to see if we're already publicly sharing them. We have them in our Enviso GitHub, so we've actually done quite some work on building them, and we've actually done another presentation at RSA where we introduced the whole concept of those frameworks. So yes, we have quite a bit of that published. Let me see if I can get you a link or hook you up with something. Yeah. Yeah. I can. In the meantime, I can check it out and grab that link.
Cool. Okay, yeah, last one, because I think this is a good point. If you have AI generate you dozens of new detections based from an imported PDF report using like RAG or whatever, the rules it generates will likely be simple
Yes.
and produce a lot of noise, right?
Yeah, 100%. So this is really where you need to fine tune the prompts, figure out, okay, how do we want to build this? I think that the generation part, where I think it can be helpful is to help automate the part where you have, okay, I now have this detection rule. How many hits do I get for the past 7 days? But yes, if it's too noisy, you will have to adapt it. So it's much more about building the entire framework and pipeline and facilitate the menial tasks, like, I have to go and check how many hits do I have. But I think that the beauty in is use that SOAR platform, add a touch of AI to it, and then have a human run with it and actually get a lot more, get a lot more work done. But you're very right. If you just have it PDF and let it go, it's just gonna come back without.
Yeah,
So
it'll be a new IDS.
yes,
All the false positives. Cool. All right. Thank you so much. Thank you very much for joining us, everyone. Hopefully this was useful to you. Again, a lot of this content comes from the SANS 599 and 699 courses on purple teaming and adversary emulation. We'll do more of these webcasts in the future. I think we've got 1 or 2 more lined up on the same topic area. So
yep.
With that being said, have a great week and we'll see you next time.
Thanks.